Hello, math students. This is our lesson on adding like terms. The learning target is I can add linear expressions by combining like terms. Let's review what a like term is. Like terms are terms whose variables and exponents are the same. Look at what I've highlighted in blue. Notice that both monomials have an x. 7x and 2x are called like terms because they both have a common x variable. You may have a variable with an exponent other than 1, like x to the second power, or we would say x squared. Because they're the same, they are called like terms. They both have a common x squared variable. These monomials are not like terms. 7x has an x variable, and 7x squared has an x squared variable. They're different. Because they are not like terms, because the exponents are different, they are called unlike terms. Only like terms can be added. Now let's review vocabulary. Terms. It's a number, a variable, or it can be several variables that are multiplied but never added or subtracted. Here's some examples. Numbers like 3, -10 are terms. A single variable like y, or variables that are multiplied together like x times y squared. You could have a coefficient like 1/2 that is multiplied by variables, and that is also a term. Like terms. Terms whose variables and exponents are the same. Like terms are also numbers without variables. Here's a list of numbers. They are all like terms. Here's a list of monomials that have a coefficient and the same variable at the same power. They are like terms because the variable is always x. Coefficient. A number multiplied by a variable. 3x. The x is the variable, so that means that the number 3 is what we call the coefficient. Constants. Constants are numbers on its own. Here is a list of lots of different numbers. They can be a whole number, a fraction, a decimal. It could be a number with an exponent. A number on its own is also called a constant. Let's look at 3 sets of monomials and identify the like terms. Identify also means that we need to be able to recognize which monomials are the same. The same because they're numbers, or the same because they have the same variable at the same power. I notice the x variable is here, here, and here. So we can list 2x, 10x, and x as like terms. Those could be added. Only like terms can be added. All right, let's look at the next set. See this y? Whoop. Here we go. See that y? Y and y and y. They are the same variable at the same power. So now let's list the like terms. Y, 4.5y, and -22y. The coefficients, which are the numbers multiplied by the variable, is not what makes these monomials like terms. It's the fact that they have the same variable y at the same power. All right, the last set. Look closely to see if you can find monomials that are the same. I'm noticing that a, x, and c are the variables, and those are all different. So the like terms are the numbers. Let's write them down. 3 2/10, 19, -12. Those 3 numbers, or monomials, or terms, are like terms. Now we're going to look at an algebraic expression to identify the terms, the like terms, the coefficients, and the constants. 8y minus 3 plus y. All right, terms are like the parts that we are subtracting or adding. So I'm going to highlight those parts. We have 8y, we have that positive 3, and the y. Those are what we call terms. So let's list them. 8y, 3, and y. Of those terms, which one are the like terms? Because they have the same variable at the same power. Notice the y and the y, that's the same. So our like terms are 8y and y. When we're looking for a coefficient, we are looking for a number that is multiplied by a variable. It's not the variable, the coefficient is just the number. So the only coefficient we have is the number 8. Constants. Constants are just numbers. And the only number that we have that has no variable is the number 3. You may want to pause the video and look at this expression on your own. See if you can identify correctly, and then press play and we'll check. The terms. Again, those are the separate monomials that are being subtracted and added. So I highlighted them, and now we can list them. Negative 22m, 2n, and 1 are the terms. Now compare those terms. Do you see any like terms? No. M and n are different, and 1 doesn't have any other number to go together. So we can say no like terms. Now let's look for those coefficients. When you're looking for a coefficient, you're looking for a number that is being multiplied by a variable. So we have a negative 22 multiplied by m. So negative 22 is a coefficient. And then let's not forget 2n. n is the variable, 2 is the coefficient that is being multiplied by the variable. So our coefficient is the number 2. Constants, just numbers, and we have the number 1. Now we're going to start to find the sum. So we're going to add linear expressions by combining like terms. When we look at this expression, we notice that x and 3x are like terms, and then 2 and 8 are like terms. One way that you can write out your problem to find the sum is by stacking and adding. So if I take plus 3x plus 8 and I bring it down and I line up my like terms, and then I can draw my line, and I'll highlight the like terms again. So see how we stacked up the x and the 3x? We did the same thing with those numbers that are like terms. And now we can add. So we're looking at x, that's a positive x, plus we're adding 3 more x's. So altogether our sum is 4x. Now this one we read as negative 2. Negative 2, and we're adding positive 8. Our sum is positive 6. So I'll write this out as our rewritten expression and as our sum, 4x plus 6. Making columns to line up the like terms is not the only way to find a sum and combine the like terms. Let me show you another way to add expressions using the commutative property. So first we need to identify those like terms. So I'm going to highlight this negative 4y and the 11y. Those are like terms because y is the same variable at the same power. We know that we can use the commutative property when we add and multiply, which means that we can change the order of our terms. We could still start with negative 4y, but we could move 11y. We would do that to keep the like terms together. And I'm just going to highlight this plus. So we've used that as well. What we have left is plus 3 minus 5. So let's add that to our expression. Plus 3 minus 5. And we can even put 3 minus 5 in parentheses. Now we can add negative 4 plus 11. That equals 7, and we include the variable y. Plus 3, and we are subtracting 5. 3 take away 5. That equals negative 2. Look at what we're left with. We have add a negative. We can simplify that by using the additive inverse. Instead of adding a negative, let's subtract a positive. So we have found the sum by combining like terms, and our equivalent expression is 7y minus 2. Now I want you to try finding the sum by combining like terms on your own. Go ahead and pause the video to work through the problem, and when you're ready, press play and we'll work through the problem together. The first step is to identify the like terms. X and 2x are like terms because of the x. It's the same variable at the same power. That leaves us with the constants or numbers. 3, 1. They're like terms. Now, one way that you can find the sum is to use the commutative property when we add. We can do that by writing x plus, and then this 2x is going to move where the 3 was. We do that to get the like terms together. Now, we have a plus. Remember, this 3 has moved over here, again, using that commutative property. So we have 3 minus 1, and we can put that expression within parentheses. Now, solve the sum. X plus 2x. We solve for the sum by writing 3x. Plus 3 take away 1. That equals 2. So 3x plus 2x is the sum of this linear expression. Now try this expression. Find the sum by combining the like terms. Negative 8y plus 4 plus 8y minus 7. Go ahead and pause the video now to work through the problem, and then press play and we'll work through the problem together. Our first step is to identify the like terms. Notice negative 8y and positive 8y. They're like terms because of the y. It's the same variable at the same power. So that leaves us with the constants or the numbers. We have 4 and 7 as like terms. Now, one way that we can find the sum is by taking this plus in our expression 8y minus 7 and just moving it down to create columns lining up those like terms, just like this. So we write negative 8y plus 4, and we're adding 8y minus 7. See how that looks? Draw the line. Now, what that does is it lines up our like terms. Those are like terms, and these are like terms. Now we're ready to add. Negative 8y plus 8y equals 0. Positive 4 minus 7 equals negative 3. And then we can finish our problem by 0 minus 3 equals negative 3. Notice what happened with these directions. They got simple, one word, simplify. We have been simplifying earlier in this chapter. Simplify means to use all possible operations to combine like terms. The first part of our expression is 2 times negative 7.5x plus 3. That is all set up for us to use the distributive property. We can spread out our multiplication to find a sum. So let's multiply 2 times negative 7.5x. That equals negative 15x plus 2 times 3 equals 6. And we can put that expression inside our parentheses. And let's copy the rest of our expression, plus 5x minus 2. Now our expression looks a little bit more like the problems we have been solving. Our first step is to identify the like terms. This negative 15x is a like term with 5x. They are like terms because of the variable x. Same variable at the same power. That leaves us with the constants or numbers. We have a 6 and we have a 2. One way that we can find the sum and simplify is to use the commutative property. We can use that when we add. So that means we could start with negative 15x. But this 5x is going to move over here. So we're going to write plus 5x. And we can go ahead and put that inside parentheses. Remember that the 6 is also moving. So we're going to copy the plus and then put the 6 there, and then write minus 2, and we can go ahead and put that expression inside our parentheses. The reason we use the commutative property, remember, is to get those like terms right next to each other. Here's a set of like terms, and here's another set of like terms. And now we're going to use all possible operations to combine like terms. So let's do that. Negative 15x plus 5x. Focus in on those numbers. Negative 15 plus 5, that equals negative 10. And we just have to include that variable x, negative 10x. Copy your plus sign. 6 take away 2, that equals 4. And now we have found the sum of this expression, and that means that we have simplified. Here's another great problem for us to try. This one is all set up for the distributive property. 1/2 times w plus 1/2 times 6, 1/4 times w plus 1/4 times 12. All right, let's go ahead and distribute our multiplication to find the sum. 1/2 times w is 1/2 w. Plus 1/2 of 6, that's 3. Go ahead and put that expression inside your parentheses. We're going to copy that plus sign. Now let's distribute. 1/4 times w is 1/4 w. What's a fourth of 12? Well, if we take 12 and we divide it into 4 equal shares, 12 divided by 4, that equals 3. And we can put that expression inside our parentheses. Do you see those like terms? 1/2 w and 1/4 w. They're like terms because of that w. It's the same variable at the same power. And then that leaves us with the numbers or the constants. We have a 3 and we have a 3. All right, I'm going to take this plus 1/4 w plus 3, and I'm just going to slide it right down, and I'm going to use my columns lining up my like terms. So 1/2 w plus 3 plus, right, we write plus, we have 1/4 w plus 3, and draw your line. All right, I'm going to highlight our like terms one more time so that you can see what we did and why we did it. We have 1/2 w plus 1/4 w, and then over here we're going to add 3 plus 3. All right, well, the 3 plus 3, that equals 6. With the fractions, we need to change those to like fractions. Notice that the denominators are different. We can change 1/2 to an equivalent fraction. We can multiply by 2 and multiply by 2. That equals 2/4. And now we're going to add 2/4 to 1/4. And that gives us a sum of 3/4, and make sure you include that variable. So 3/4 W plus 6 is our simplified expression. All right, our last problem I have left for you to try it. You're going to simplify it. Go ahead and pause the video now, work through the problem, press play, and we'll work through it together. When I look at the beginning of this expression, I notice that we have two groups of negative 4x plus 6, and we can use our distributive property knowledge to simplify it. 2 times negative 4x equals negative 8x, plus 2 times 6, that equals 12. And we can put that expression inside parentheses, and now we're just going to copy what's left, plus 9x minus 7. Now, you may have used the commutative property with addition to move, or you may have stacked up your like terms. So let's just identify those like terms. We have negative 8x and we have 9x. And then we'll highlight our constants, which are our numbers. We have positive 12, and we have this 7 over here. So I think I'm going to take this expression and I'm just going to slide it down. I'm going to stack up my like terms. So negative 8x plus 12. And then we're adding, right? So we're going to put plus 9x minus 7. Draw your line. All right. I will highlight our like terms again, just so you can see what we're doing and why. We can only combine like terms. So that means we can take this negative 8x and we can add 9x because they are like terms. Same variable at the same power. What's negative 8 plus 9? That equals 1. Now we can simplify it and just write the 1x. Then what's happening over here? We have a positive 12. We're adding a negative 7. So let me just rewrite this. 12 plus, and I'm even going to just write it horizontally because you're kind of used to seeing it like that. If you look at the plus, if you look at these two symbols, we can change that. We can simplify, use the additive inverse, do the opposite sign change. Instead of adding a negative, subtract a positive. It's a lot easier to subtract 12, take away 7. That equals positive 5. Positive 5, right? 12 take away 7, that equals positive 5. So right here we can circle it. Our simplified expression by combining our like terms is x plus 5. All right, great job.